Good evening, everyone. I hope everybody can see me and hear me. Welcome to today's evening session, students. I have Likhit, Neha, Mohammad Azam, Nukul, Manan, Shata. Very nice to see all familiar students regularly attending classes day to day. It takes a lot of effort, right, to be regular and to study regularly. We have a new student in class, Yuvraj. How do you hear me, Yuvraj? We have Abhiroop also joining us. Abhiroop, how do you hear me? Can you hear me well?
Yes, sir. I can hear you well.
Very good.
Radio 5, Victor Tango Alpha Bravo Hotel.
Good. Very nice reply. And how about you, Yuvraj?
Yes, sir. I'm new. I can hear you well.
Good, 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 good. Everybody is new for metrology. Today is your first session. So welcome. Some students are learning other subjects. They are with me for other subjects in some time. So new and old. But today everybody is new. It's a first lecture for metrology. Metrology is one of the easiest topics that you'll ever come across, but it requires focus. And it requires focus on 5 important elements. Today I'm going to introduce those elements to you. Okay. But before we just randomly get started quickly, let's just give a couple of minutes to couple of students to join us. I am thinking, I think everybody is here, just Lakshya is yet to join us. Okay. Abhiroop, nice to see you. I think I'm looking at you for the first time. Nice to meet you. And Manan, Nukul, and Mohammad Azam, again, nice to meet you all. Day to day, I feel good about looking at myself also. Students, you know the joke. The beard is coming back and I feel good about it. So Abhirup, we had this joke, after a long time, I just got rid of my beard and then it got really funny. And a lot of students told me, sir, you look funny. You've broken our heart. So that's a joke that I crack on myself. Otherwise, it gets very difficult, to look at the screen and teach when we don't recognize ourselves. It is not metrology, okay? It's just out of topic. So, Abhiroop, tell me, were you able to watch the session from yesterday? How much? Did you understand anything?
I just started watching around half an hour video time I had watched.
Okay.
So I did understand in bits and pieces.
It's a very generic session, talking about very generic explanation about what is what and what is what. In the next half of the regulations lecture, you'll come across how to find out where the rules and regulations are. So keep at it. Whenever you're free, try to look at it, settle down, get used to it. Okay? Good. Lakshya, for you, it's going to be some sort of revision. How do you read me, Lakshya?
Victor Tango Lima Alpha Kilo, I read 5.
Great. I also read you 5. And Yuvraj, as it's your first session, I'm not sure if you have gone through other classes. Yuvraj, please give me a brief. Have you attended other sessions? Have you taken metrology classes or other subject classes? Have you gone through any of our videos before? Just give me a brief about yourself, Yuvraj.
No, sir. I didn't take any classes, but I saw your videos on YouTube. So I got information from that. So I contact you tomorrow.
And
Sorry, today.
Today you messaged me exactly on time about metrology requesting password. Did you get an email?
Yes, sir.
How did you figure that out? Or did you see it on Instagram or did you get an email?
No, actually, I enrolled so many months ago, like October, in October. So I have your email that coming in my mail. So
Okay. Okay, nice, nice, nice. I knew that I have spoken to you earlier, but good to see you finally after so many days. So, students, as it's your first session, there's going to be introduction about the topic, and we are going to talk about a strategy as to how the entire training course is going to be for this particular topic for you. Okay. So, Neha, Shweta, Mohammad Azam, Nukul, Manan, you know the drill. Likit, you know the drill, how we go about it. But that being said, we have to have our eyes and ears open and understand, because metrology, what is metrology? It can be defined in simple 5 to 6 words. It's the science of atmosphere. And what is atmosphere? Everything that you see around you, which is not ground, which is not land, anything above that land can be recognized as your atmosphere. Okay. Now everybody is sitting in some sort of room, some sort of place from where we are attending the session. The air around us is a part of the atmosphere. The air around me is part of the atmosphere. The air outside the window is part of the atmosphere. Everything. We breathe in air, we exhale air, that also is a part of the atmosphere. So when we say the science behind atmosphere, it means we need to learn about important elements as to how this atmosphere behaves and what are the properties of atmosphere, different properties. And why do we need to learn that? I need atmosphere to fly this aircraft. I need air to flow over the wings. These are the wings. I need air to flow over and below the wings to give me what is known as lift. This is something that you're going to learn in your technical lecture tomorrow, first session for a fresh technical batch. I also need air to feed into my engines to give me what is known as thrust, the forward moving force. This air makes up your atmosphere. So your atmosphere is a mixture of different types of gases. So where does this gas come from? Oxygen is a gas, carbon dioxide is a gas. Any element of matter which you cannot see but which exists can be termed as gas. Some things that you can smell but you cannot see can be termed as gas. So atmosphere is basically air, AIR, and this air is a mixture of a lot of different gases, and not just gases, but there will be dust particles also, and then there will be water vapor also. What is water vapor? Water which is evaporating in the form of vapor or in a gaseous form. It is still water, it is not a gas. So all these elements that I'm talking about right now, our initial target would be to slowly understand all these little points and master these little points. When you master these little points, your further properties of atmosphere become very easy. It's like, let's talk about, these are two properties, property A, property B. If you understand the relationship between the two, that if this increases, this decreases, then your job becomes much more easier to understand a lot of things in future. It could be pressure, density, it could be pressure, temperature, or it could be temperature and pressure. These are the elements. Okay, so what is atmosphere? There will be a couple of definitions that I'll be giving you. You will write down in your notebooks. So make sure you have your notebook, a separate dedicated notebook. Mostly the textbook from Mr. I.C. Joshi. He's authored the textbook. It's very good when it comes to DGCA aviation metrology examinations, and understanding and explanation is also good. But that is not the only book that we'll refer to. We'll keep that as a base, and we'll be referring Oxford textbooks and any other textbook that supplements our information. So all this information you will be getting. You should give yourself at least 2 to 3 sessions in the beginning to get comfortable with the topic, metrology. Okay. And then slowly we will increase the pace of how we are learning and what we are learning. And remember, you have to enjoy. You have to have a lot of fun when you're learning it, be it for 1 hour, be it for 1.5 hours, be it for 2 hours, be it for 3 hours. Right, students? So we need to remind ourselves that, okay, let's smile and let's study and let's have fun for a couple of hours, more or less. Let's just enjoy this and learn something that is going to help us become better pilots. Now, again, why is it important to study atmosphere for you as a pilot? Just because the aircraft will get lift and the engines will give thrust? No, there are more patterns that can disturb your aircraft performance if you don't focus on them. So, like a heavy thunderstorm, why would a thunderstorm exist in the first place? Is something that you should learn. What are clouds? What is the adverse effect of clouds? How are clouds formed? What is wind? You must have seen so many videos of landing aircrafts taking off in heavy winds, crosswinds. Winds are very bad. Are all winds bad? No, but strong winds are bad. So what are winds? Then what are seasonal changes? And then how does rain come in picture? What is the effect of rain, snow, hail? So all these elements, you will learn about everything. But do you think you will learn about everything on PhD level or master's level? No, you will be learning only at CPL level, and CPL level is basic level students. That's why I say it's the easiest of all topics. But initially it will be tough, okay, because you will be going through new terms and you might be thinking, okay, you lose focus and you will miss a couple of explanation points, and that will become a negative point for you because you miss that. So now you don't know what is the meaning of that particular term. Whenever that happens, you raise your hand, you put something in the chat box on Zoom and tell me, sir, can you please explain what is the meaning of this term? These are just words having different meanings, students. Words like synoptic charts, aerosols, greenhouse gases, cyclones, anticyclones, isobars. So what are these words? These are just words that talk about different elements. So we don't have to feel threatened about them, but we just have to see, okay, this is something new and I'm going to learn and I'm going to enjoy it. And I'm going to make sure that whenever my metrology exam comes, I'm going to crack it in my first attempt. Simple. There will be numerous strategies which I'll give you, but not at the cost of knowledge. First, we'll focus on knowledge. And all that we are learning is for knowledge. Mainly knowledge, then clearing examinations. Both work hand in hand. For students who are always confused about what's the spelling of meteorology, it used to happen with me also. Not that it matters, but it is important that we get it right. The first thing. Okay. So I'm going to share the whiteboard and I'm going to start making a couple of pointers, give you a couple of notes. Then I'm going to show you what atmosphere is about. What are the different layers of atmosphere? What are the different gases? And then we are going to discuss important points about this atmosphere. And then we're going to talk about certain standards that aviation professionals use in the design and the operations and the certification of aircrafts. These standards really are very important in your day-to-day operations also. So the first chapter is important chapter from the textbook. Today, what we are learning is introduction to atmosphere, introduction to metrology, and so on. Okay, students. Let me. Ayan, how do you read? Victor Tango Alpha Yankee Kilo. Ayan, can you hear me properly? Okay, good. Nice to see you, Ayan. Join after a long time. This is the first session for metrology. Let's see how you find it. So before we start, I want to know what you think as a beginner, as a fresher about metrology. Okay, so let's start with Nukul. Nukul, what do you think is aviation metrology?
So it's a study of various different type of terrains, atmosphere, air, and and various gases which are present in our atmosphere.
Okay, study of various trends, like you're saying. I can take that as an answer. Not bad. Manan, what do you think is metrology? Of course, I have given a description, students, but try to give me an answer from your point of view also.
Meteorology is the science of atmosphere. It is a study of atmosphere, winds, terrains, pressure, density, humidity, fog, everything which takes place in our day-to-day life in atmosphere.
Okay, correct. I can take that as an answer. Questions like this, they don't have a right or a wrong answer, students. Okay. Mohammad Azam, your turn.
Aviation meteorology is the study of weather in a unique perspective of an aviation industry.
Say again the last sentence. I could hear you too. I could read it.
Aviation meteorology is the study of weathers and in a unique perspective of an aviation industry.
Study of weather from a unique perspective of aviation industry. Correct? We can say that. Half of the things that you will study would be with respect to an aviation perspective. Half of the things would be from a generic perspective. Okay, good. Abhirup, share your views.
So, aviation meteorology is the study of the atmosphere around us and how it is going to affect how it's going to affect the performance, and overall how it's going to affect our flight. What the flight has to do with the atmosphere at all, something like that. The relation.
Study of elements, correct. Study of elements and what's the impact of these elements on your safe operation. Yeah, you can say that. A very well defined answer. Everybody is giving me the right pointers because we all understand this is what we are going to study, right? It can be explained in one line, it can be explained in two lines. But then, why do we have a whole set of 20 chapters, 30 chapters, and why do we have to study so much? Because those are different elements. It's like studying about a tree. If I tell you there is a tree, you'll be like, yeah, that is a tree. Okay, it is explained that is a tree. It has a trunk, it has branches, it has leaves, it has flowers, it has fruits, it has roots, right? But then if we go into detail, then we talk about the roots, we talk about the seeds, we talk about the flowers, different stages of flowers, different stages of fruits, branches, age, and how the tree will shed its leaves in different seasons. So a single tree can also be divided into 10 to 12 chapters. Similarly, atmosphere is divided into multiple facets or phases, and that is what we are going to study. Good. Shata, what about you? Share your views.
So aviation meteorology is the study of atmospheric properties like density, pressure, temperature, and the composition, and the study of weather elements that affect the course of flight.
Correct. See, the more answers we listen, the better is our description. Now, Shata is giving us such a very clear explanation based upon a combination of all the explanations that you are giving. Yes, correct, Shata. Thank you. Very good. Neha, what about you? Please share your views.
Aviation meteorology is study of weather from different perspective, which is help, which is and how it is helpful to the aviation industry.
From perspectives, a study of weather from different perspectives and how it affects or helps aviation. Correct. So we will not be learning about those parameters that are not a part of aviation. But to be honest, students, all elements of weather impact aviation, because we fly in air, right? We don't fly on ground. We fly in air. And whatever happens to air, there will not be a differentiation between, okay, aviation will only be given these properties and other properties will not be there. But yes, there are certain properties that impact more than other properties, and that differentiation is something which we can account for. But overall, everything that is an element of the atmosphere and weather will impact our aircraft operations. Like we can say that oxygen is good for breathing. We need oxygen to live. We need carbon dioxide also. We need nitrogen also. But specifically, does the aircraft need nitrogen? Does the aircraft breathe oxygen? No. So that is the difference. But does the aircraft need air as a mixture of oxygen, carbon dioxide, nitrogen? Definitely yes. It is like that. Okay, good. Lakshya, you have had gone through a few sessions. I know you have some base knowledge on meteorology. Please share your views.
Yeah, basically, so it's the study, we can say by the bookish knowledge, if we go by the bookish knowledge, then we can say it's the science which deals with atmosphere and its phenomena, including both weather and climate. And like it is, meteorology is basically study of weather which is used for safe operations of flight from point A to B.
Mm-hmm.
And it deals with many things like uh, layers of atmosphere, where commercial flight happens, what's the ratio, things about ozone.
Correct. Now you're trying to think about what you have read in the books, in the topics. Very nice. So we have got an idea, students. Okay. Not everybody is speaking about it, definitely, but we get a gist of it, right? Now, give me a couple of minutes. I'll start showing how the atmosphere looks like. Okay. Atmosphere has layers, like there are layers in a cake. Okay. You see there are different layers, chocolate and cream and this and that. Atmosphere also has certain layers. How do we know these layers exist? A lot of scientists, they have studied this atmosphere. And in recent years, satellite images and high altitude aircrafts and experimental aircrafts have helped us understand and design or picture the real design of the atmosphere. And this design of the atmosphere is very important. Okay. Now, if I say the aircraft flies in the atmosphere, okay, fine, fine. Everything is about atmosphere, great. But what part of atmosphere does the aircraft fly? Now that, okay, I don't know what part. Are there parts? Yes, there are parts. So that's what we'll start with. What are the different parts? And understand there is a force on Earth known as gravity. And gravity is such a force that pulls gravity is such a force that pulls everything towards the ground. If your aircraft is not supported by the lift in air, then it will fall down due to gravity. Okay. If I leave you midair without a parachute, you'll fall rapidly down due to gravity. With the parachute, you will be having a controlled fall. Simple, but you will still fall. This atmosphere is also attracted to the ground due to gravity. So majority of your atmosphere, okay, majority of your atmosphere is on the lower altitudes of the earth. I'm going to show you in diagrams. All these points are important points. You will see all that I'm talking about right now, at least 2 to 3 to 4 to 5 to 10 questions can be formulated out of these basic points. Just give me a second. So this planet Earth, this is not atmosphere, but everything surrounding it is atmosphere. Now, nobody knows how far the atmosphere goes. Okay. The atmosphere can go up to 400 kilometers. Some people say it goes up to 800 kilometers. Some people say it goes beyond that. In reality, nobody knows where exactly atmosphere ends and space begins. Space, the reason space is called space is because it does not have air. It does not have atmosphere. Okay. So there is a very gradual decrease of your gases as your altitude increases. So let's get started with few key points. Students who have not spoken about what metrology is right now, I'll be asking you other questions. Okay. So be ready to share your views. If I have to talk about what is metrology, simple. Metrology is the science of atmosphere. Just a second, students, I'm facing difficulties in uploading the whiteboard. In the meantime, students, have you ever come across weather phenomena that has impacted your day-to-day lives? Have you ever experienced something that you can share? Maybe during flight training, maybe during watching a movie or something, or maybe when you were just, on a hill station, maybe you were driving a car or a bike or a bicycle, maybe holding an umbrella, something or the other. Have you ever experienced extreme weather phenomena? I remember there's one hill station in Maharashtra where the winds are so fast that there is a waterfall, and because of the winds, the water that falls from the waterfall, it is again pushed back in air. We call it reverse waterfall. So the water should fall down from the waterfall, but because of heavy winds, the water is sprayed back up. You should watch out videos for that place in Maharashtra. It's a reverse waterfall. So that's the impact of winds. And if you stand there, certain points, you can feel the wind pushing you. And talking about heavy winds, you all must have seen cyclones and hurricanes and how they take along with them cars and bikes and even airplanes and houses also and trees also. So what is this mass of air, that big tree or a house? It's air, and air is nothing but gas particles. They have mass, they have density. Just like my hand right now. Okay, if I'm holding something, I'm lifting it, air can also lift something because air also has mass. Remember that. These all. So first point, what is metrology? Just for our understanding, metrology is the science of atmosphere. Then if I have to ask, what is atmosphere? I will say atmosphere is a homogeneous mixture, a very good mixture of gases. called air. So the air we breathe, it's not just oxygen, students, it's everything. We utilize oxygen for our blood supply and everything else essential to our health. But there are other elements also that go in. Okay. So everywhere around you and around me, we have same air, just the proportion of these gases is going to be different. What is atmosphere? Atmosphere is a homogeneous mixture of gases called air. Simple. Okay. Now, if I have to ask, which all gases are there in air or in atmosphere? Which all gases? Then I have nitrogen. Then I have oxygen. Then I have argon. A few of gases you might have never, actually made any relationship with, because you don't know if they relate with you or they don't relate with you. But these are major gases. Carbon dioxide. Okay. Then I have neon. I have helium. Helium is a funny gas. Okay. We call it a funny gas. Methane. Krypton or krypton. Xenon. See, so many gases. Okay. I'm just writing the names of these gases. Iodine. Hydrogen. Ozone. Ammonia, the gas with a very bad smell. Nitrous oxide. Are you required to remember the names of all these gases? Not really, but you should be aware. Okay. Carbon monoxide, not good at all. Some of the gases can be deadly also, students. Of course, carbon dioxide is there. Sulfur oxide is there. And nitrogen dioxide is there. And a combination of all other gases can also be there. But these gases are naturally available. Out of these, this list of gases, starting from neon, helium, methane, krypton, and all, we have only traces in atmosphere. The quantity is very less. These are rare gases. We won't say rare as precious, but the major gases are these, nitrogen and oxygen. And nitrogen is about 78% of the entire atmosphere. It's shocking, right? We think oxygen covers up the entire composition of atmosphere, but it's not oxygen, it's nitrogen. Then we have around 20% of oxygen. Oxide, although very important, is only 0.05%. These are rounded off values. The actual values are 78.09%. Now, one of these questions can come in the exam about nitrogen or oxygen. Oxygen is actually 20.985%. Argon is actually 0.983. 9 I call niner, okay? It's the radio telephony lingo for 9 in aviation. And carbon dioxide is actually 0.035%. So 70, 80, 98, 98, 99, almost 100% is made up of all these gases. these four gases? 100% of air or atmosphere? What are basic properties of these gases? Basic generic properties. Now, we are not going to talk about what is nitrogen going to do, what is oxygen going to do, what is carbon dioxide going to do. Basic properties is these gases have mass. These gases, they occupy space. Okay? These gases have density. These gases exert students, can you hear me?
Affirm, sir.
Yeah. So these are basic properties of these gases. They are just like any other matter. Abhiroop, Yuvraj, are you following?
Affirm, sir.
Sir.
Write down note. In addition to these gases, air also has water vapor, WV, and certain solid particles. These solid particles could be dust particles, molecular level solid particles coming out from industries, factories, household kitchens, stoves, everything else. My entire air or atmosphere, let me show you in a small diagram first. Then I'm going to teach, not teach, but show an important point. If this is Earth, how does the atmosphere look like? On the Earth, there are certain elements that go by this. There is a line that divides the Earth into equal hemispheres. This line is known as equator. Equator divides the Earth in two parts. On a real globe, this is the equator. Wait. Okay, you cannot see it because of the brightness, but over here, there is a line that will divide the Earth. What you can see half, the semicircle from top is the equator right now. And what you see on the poles, the top and the bottom of the Earth is known as the polar region. Equatorial region, polar region. This is the equatorial region. This is the polar region. The polar regions are always having a lot of ice. And the equatorial region are always having a lot of sunlight or heat. Okay. So these are poles of the Earth. This is North Pole. And this is South Pole. Atmosphere is arranged in such a way that it looks like this. What I'm showing you in blue is this homogeneous mixture of gases. Over the equator, the gases extend up to a higher altitude. And over the polar regions, the gases don't have a higher altitude as compared to the equator, like this. So what happens is, on the useful atmosphere, the useful atmosphere on the equator is more, or the altitude, the height, the vertical distance from the ground is more, where we have more homogeneous mixture of gases compared to the poles. There are multiple, but it's because of the sun, the heat from the sun. Now, talking about the different layers, in a 3D diagram, your layers look like this. This is still not 3D, but it covers up the whole Earth. I was talking about different layers like a piece of cake. There'll be another layer. Then there will be another layer. Like this. And there will be another layer above this layer. Such is my atmosphere extending out in space. But majority of atmosphere, majority of gases, what is the altitude that majority of the gases are stuck close to the Earth? Students, up to 6 kilometers, you have half of the entire atmosphere. From zero, that is ground level, till 6 kilometers above. How much is 6 kilometers in feet? Students having navigation computers, you can do it. If you want to do a manual conversion, you can write down this. 1 kilometer is equal to 3280 feet. So 6 kilometers would be 6 into 3280 feet, 19,680 feet. So up to 19,000 or 20,000 feet. We talk in feet only because all our aircraft altitudes are recorded in feet, students. So up to 20,000 feet, half of my entire atmosphere is located. How much? Half. Are you getting it, students? So whatever you see in red and yellow, although there is atmosphere and gases, the quantity of the air molecules or the homogeneous mixture of air is reduced or is less. Majority of it is up to 6 kilometers, and this is due to the force of gravity. Remember that. Up to 10 kilometers. Up to of my entire atmosphere. How much is 10 kilometers? In thousands of feet, 10 into 3280, 32,800 feet. So 6 kilometers gives me around 19,500 feet, rounded off value. And 10 kilometers gives me 33,000 feet. Students, you will be surprised to know that majority of your flights, they fly in a range of 30 to 40,000 feet. Of course, they start from 5,000, 6,000, 7,000 feet. They go up to 30 to 40, 30, 35, 40, up to 46,000 feet maximum. We have commercial airspace flights flying. So up to 6 kilometers, I have half of my atmosphere. Up to 10 kilometers, I have my 3/4 of my atmosphere. Okay. And if I have to extend it till 35 kilometers, Okay, 35 kilometers. Then my majority, 99% of my atmosphere is limited within 35 kilometers from the surface of the earth. How much is 35 kilometers when we travel by road? It is not too much. We can reach in half an hour, 1 hour, 1.5 hours, depending upon the road, the traffic. The same thing you try to go vertically. It's very difficult. But the distance is not too much. The distance is not too much. The distance is not too much for what? The distance is not too much for the percent of the atmosphere. And it is only up to 35 kilometers. So if I say below 35 kilometers, how much is 35 kilometers in feet? Gives me 114,800 feet. Experimental aircrafts, they fly up to this level. There are certain aircrafts, they fly up to this level. So my homogeneous mixture of air.
Sir, it's 114800, right?
Correct, 114800. These are rounded off values. So now you know the majority of the atmosphere existing at which levels. But is this enough to study? No, it is not enough to study. Why? Because there are more elements to it. Majority of your flights, they will take place in what is known as troposphere. What is troposphere? I am going to show you. You see the blue shaded area? Let's say the blue shaded area. So the entire blue shaded area is troposphere, troposphere. The word tropo comes from the Greek letter known as turning. This is a question, okay? It will be there in your books. And sphere means earth. So troposphere behaves as if it's a part of the earth. So if the earth is rotating 24 hours, once in 24 hours, the troposphere will also rotate with earth. As if it's stuck to earth. It is not like, let's say that this is a part of the range of troposphere. Stay stationary. It is also going to rotate with the earth like this, like this, like this, like this. It is a part of the earth itself. Okay. So troposphere is the first layer of atmosphere. And majority of the flights, they exist in troposphere only. Majority of your clouds, majority of your weather phenomena, everything that you're going to study happens majorly in this troposphere. And what is the height of troposphere from ground level? Students, the height of troposphere from ground levels, I'm going to, for the lack of, so I'm going to erase this North Pole that I have written down so that I get some space. North Pole, South Pole. Okay. Students, are we following? Everyone? Is anybody confused? Is anybody thinking what's happening? So the troposphere in the polar regions, okay, North Pole, NP, and 8 to 10 kilometers. Remember this, a very important point. The height of troposphere, the first layer where majority of weather phenomena happens, where majority of the aircrafts fly, in the polar regions, the altitude goes up to 8 to 10 kilometers. And in the equatorial regions, it goes from up to 16 to 18 kilometers. That's why you see the shape is oval and not a perfect circle. Are these points clear, students? You need to memorize these points. Now we have swiftly resumed from a generic explanation and a generic introduction of atmosphere to key points and key elements that are going to be part of your examination questions. What is the first layer? Troposphere. What is the meaning of troposphere? Greek letter turning with sphere. What is the altitude of height or thickness of troposphere? Polar regions 8 to 10 kilometers. Always know how to convert it into feet also. Equatorial regions 16 to 18 kilometers. Remember the first thing I said, equatorial region will have more atmosphere, higher level of gases, or gases will be there at higher levels on the equator. So how much is 8 to 10 kilometers? We know 10 kilometers goes to 33,000 feet. So an average is taken out of this. Okay. An average is taken out, students. And wherever the troposphere ends, there is a layer. Of course, the layer is invisible, but it is very important. This layer where the troposphere ends. Okay. Layer where is called, now this is very important, tropopause. Very important point. Knowing about to 18 kilometers on the equatorial regions are the height of the tropopause. Are you getting it? We can say this is the height of the tropopause because tropopause is where the troposphere ends. Now there are multiple reasons to it that I'm going to show you in a, but we need to remember troposphere is the first layer. Majority of atmosphere is in troposphere. Up to 3/4 of atmosphere is in troposphere, more than 3/4 because it goes up to 16 to 18 kilometers on equator, and up to 10 kilometers, I already know I have 3/4 of my atmosphere. So troposphere is something that is of prime concern to you, to me, to everyone. And all that is happening is majorly happening in troposphere. All clouds only occur till tropopause. Only two types of clouds go on to higher levels. I'll give you the names of those. And they are rarely seen. Clouds can obstruct your visibility and clouds could develop into storms also. So, yeah. You have a question? Your Victor Tango Alpha Mike Alpha, Mumbai Control, how do you read?
Media 5, sir. The North Pole distance and South Pole distance are same, right, sir? 8 to 10 kilometers, 8 to 10 kilometers.
8 to 10, 8 to 10, yeah. North and South, both same distance. 8 to 10 kilometers, 8 to 10 kilometers.
So then topopause is like 16 to 18 kilometers in west and east. So what is that 6 kilometers? Like why we have given that 6 kilometers? We can just, it's 16 and 18 kilometers itself, right?
6 kilometers tells you that half of the total atmosphere is within 6 kilometers. If I say that there are 100 molecules of atmosphere in the whole atmosphere till it merges in space, and the whole atmosphere is up to 800 kilometers, let's say, then half of it, that is 50 molecules, are within 6 kilometers. That is the description. Tropopause is different.
Yes, I got it.
Tropopause is where troposphere ends. it means all weather phenomena ends. All movements of your weather, winds, everything ends. After that, we have atmosphere. It is not as, what do we say? It is not as vibrational as troposphere. When I say vibrational, it means it is not stagnant. It has a lot of things happening in itself. It is not stationary. Okay. So 6 kilometers is just showing me that, okay, up to 6 kilometers, I have majority of atmosphere. But up to 11 kilometers, I would say that an average tropopause exists up to 11 kilometers. But in reality, on the polar regions, the tropopause goes up to 8 to 10 kilometers. And on the equators, the tropopause is going up to 16 to 18. Remember, students, these points, the more you will revise, it will become strong in your head. So now, when I have to show you this entire thing about my troposphere and all, so I start like this. My ground level, okay, GL. From my ground level, I have tropopause. So in between tropopause and ground level, I have troposphere. After troposphere, I get into another layer known as stratosphere. It's just a name given to the next layer, stratosphere. The stratosphere ends at another line similar to tropopause known as stratopause. These are different layers of gases because they have specific properties during the entire layer or around the entire layer. The whole tropopause, or let me reiterate, the whole troposphere will have similar properties. Beyond troposphere, that is beyond tropopause, the properties will change and they will remain constant till the time you reach stratopause. So after tropopause, changes the properties of my. What is this property? This property is the property of temperature. But wait for it. We will not directly come on to temperature. We'll just study these layers first, and then we'll simply see how the temperature behaves. So there is a lot of different things that are going to combine like a jigsaw puzzle and make a picture. Wherever you get confused, make a note of it, mark that point, share with me, and take a pause. We don't have to force it on you. We have to let your mind grasp it naturally and slowly. These are building blocks, basics, right, students? So we should not be in rush, okay? Because when I realize I'm speaking continuously for 40 minutes, I think I'm giving my students a lot to download in their minds. Which is the next layer of atmosphere after stratosphere? Very simple. It is called as mesosphere. And just like the other layers, mesosphere will also end at a line which is called as mesopause. And after mesopause, I have another layer known as thermosphere. Beyond this, I don't need to understand my atmosphere. If you are wondering, sir, what have you made these 4 parallel lines, crooked lines? I don't understand. Then I'll show you. This is a line indicating altitude, like a graph. And this line on the ground level, X and Y of a graph, this line will indicate temperature, and this line will indicate altitude or height, like this. So this is my tropopause, stratopause, mesopause, thermosphere is there. So far, so good, students. How many students are confused? How many students are thinking it's not your cup of tea? Raise your hand, speak up, let me know. Anybody who's finding it difficult to understand so far, let me know. Good. Even this troposphere, students, is divided. Let's write down these three layers also. Even this troposphere is divided into three layers, which is a lower troposphere, a middle troposphere, and an upper troposphere. So this is lower troposphere, middle troposphere, and upper troposphere, like this. Why are we dividing troposphere? Because troposphere is our main atmospheric layer where majority of our flights are going to happen. That's why. So talking about atmosphere, we will be majorly talking about troposphere. And in your textbooks, you will see the height of lower troposphere is also given to you. Lower troposphere goes up to 2.1 kilometers. From middle troposphere goes up to 7.6 kilometers. And upper troposphere goes up to tropopause. These are average values. Real values would be somewhere around a little more, a little less. Before I talk about the effect of temperature, I'm just going to come back and talk about these gases. An important question that is often asked in the examination is, because the two important gases are nitrogen and oxygen, what is the ratio of nitrogen to oxygen by volume? And what is the ratio of nitrogen to oxygen by weight? Okay, it's a very simple figure. We will write it here. Important point. Ratio of nitrogen to oxygen. Okay. By volume. What has three dimensions: length, breadth, and height. Water inside a glass would be volume. And if I don't have a glass, but I have this, a diagram of a glass, then it is not volume, it is area. Okay, it's two dimension. So by volume, what is the ratio? And by weight, what is the ratio? Remember these points, and then we'll take a short break. And after that, I'm going to introduce temperature to you. Okay, temperature with respect to these layers. So any guesses by volume? Nitrogen is 4 parts and oxygen is 1 part by volume. And by weight, nitrogen is 3 parts and oxygen is 1 part. These are so by volume, nitrogen is more. Oxygen is just 25% compared to nitrogen because 4:1. By weight, oxygen is 33% of nitrogen. We can say that. That is 3:1. Okay, students, remember this ratio. Everybody, let's come back in 10 minutes, 7:15 sharp. Take a short break. Okay, it's 7:05. Come back in 10 minutes, 19 or 15, and we will talk about these layers and a few other key points talking about your atmosphere in detail. All right, I'll see you in 10 minutes, students. Welcome back, everyone. Sorry for the short break. I know 10 minutes are not enough, but just a breather. I think 15 minutes should be given, but we don't have a lengthy session today. We have a short session. Is everyone back?
Sir.
I am missing one student, but it's okay. I think Zai Prakash is missing. Students, so far, were you able to make sense of all that I have said and shared with you? Do you understand? All of a sudden, talking 7 to 8 times about what is meteorology, science of atmosphere, to actually discussing atmosphere, gases, mass, height, troposphere, tropopause, so many spheres. Are you making sense of it? If no, please let me know. If you're not saying anything, it means you're making sense. Neha, Ayan, Shraddha, Yuvraj, Lakshay, Likit, and Mohammad Azam. Are we all back?
Affirm, sir.
Affirm, sir.
Affirm, sir. Victor Tango November Echo Hotel.
Affirm, sir. Victor Tango Lima Alpha Kilo.
Good. Very good.
Affirm, sir. Alpha Mike Alpha.
Roger. Good job. Okay. Now, what I'm going to show you now, okay, what I'm going to show you now is called as the thermal structure. Okay, this altitude is in height, okay, altitude or height in kilometer. So what I'm going to show you now is thermal structure. Wherever the word thermal comes in, students, it means temperature. Okay, thermal means temperature. You need some heat. Temperature doesn't really mean heat. Temperature can also mean temperature. Negative temperatures, minus and plus. Okay. This thermal structure is very important. One of the main backbones of your entire metrology training course. If you miss certain elements about the thermal structure, you will not get answers to certain numericals. Yes, you will be solving certain numericals in metrology also. Okay. Today, we will talk about the thermal structure in short, just as an explanation. And I'm going to give you certain values that are standard values as adopted by something known as International Standard Atmosphere. That's it. We will see how much we can cover. I think the screen is frozen. Students, are you there? Yeah. So what I was saying was, what I'm going to do is, after I discuss these points, there will be a few more points that you will be required to read, okay, from the textbook. So what I'm going to do is, I'm actually going to make a PDF otherwise, and I'm going to share that PDF with you. I would want you all to read it before your next metrology lecture to get more insight about a few more things and learn about more things that I'm not discussing right now in class. And then when we have the next lecture for which you'll get the schedule, definitely next week, we will have the next lecture for metrology. That's when we will discuss, and I will see whether you can learn and study reading by yourself also a few things that I'm not openly discussing in class. Okay, so that would be the agenda for that. Now, talking about thermal structure, I'm going to pick up a point on the ground level. Okay, and this point that I'm picking up right now, I will say this is 15 degrees Celsius temperature. This point, I'll write it in red. Okay, just try to understand this diagram. Now, what happens in troposphere is, as your altitude increases in troposphere, as your altitude or height increases, the temperature falls. Note, in troposphere, as height increases, a very important point. But in bracket, you will write only up to tropopause. So another importance for tropopause. Definitely not really up to tropopause, but then we can say up to only up to close to tropopause. Only up to close to tropopause. After tropopause, when we get into the next sphere, that is stratosphere, something else happens to the temperature. It will students, now look at it. If this is 15 degrees, okay, I will say this is 20 degrees, this is 30 degrees, and here I will say I'm going to 0 degrees, and then I will say that I'm going to, minus 56 degrees Celsius, and then again minus, let's say 90 degrees Celsius or so. So to show you a scale of temperature, on this side is positive, on this side is negative. Okay. Now what is happening in troposphere? The temperature is falling. How? Like this. Ground level, I can assume my temperature is 15 degrees Celsius. It is a standard value that I have adopted for certain tests and experiments in aviation and for navigation also. Is it always 15 degrees Celsius? No. You can check the temperature around your area. It could be 20, it could be 25, it could be 30, it could be 14, it could be 10, it could be 5 degrees also. 15 is an average that we take, a standard value that we take. So in the troposphere, the temperature falls like this. And it falls up to tropopause or a certain altitude. I can say the altitude goes up to 10 kilometers or 11 kilometers. So this is temperature falling up to minus 50 degrees or minus 56 degrees Celsius, this value. What happens after this? After you cross tropopause or after you cross troposphere, okay, or after you cross this altitude near to tropopause, we will not say tropopause, we'll say near to tropopause, then your temperature starts to rise again slowly, and it goes up to stratosphere like this. This area can also be called as isothermal area. Thermal means constant temperature up to certain altitude. Up to 20 kilometers, I will say my area is isothermal. It is almost constant. So this graph, although it looks like the temperature is increasing, the difference is very less. Isothermal means constant. Whenever temperature falls with altitude, it is known as lapse rate. Write this down. Whenever temperature falls with height, or whenever temperature falls height increases, it's known as lapse rate. Okay, lapse rate. And this lapse rate has a value, students, 1.908 degrees Celsius per 1000 feet, or 6.5 degrees Celsius per kilometer. So 1000 feet, you're going to have a drop of 1.908 degrees Celsius. If you are rising 1 kilometer up from ground level, there's going to be a drop of 6.5 degrees Celsius. So from 15, you will deduct 6.5, that will be 9 degrees or something. We will discuss more about the lapse rate, but temperature rises with or as height increases, it is known as inversion. Remember, students, these are important terms. We are going to study them in detail again. These are just terms. So inversion means temperature increasing with height. Lapse rate means temperature decreasing with height. Up to 11 kilometers or so, our temperature falls at 1.908. This is again ISA value. I'm going to give it to you in writing again. Okay. In green, write down another note. When temperature remains constant with height, it is known as isothermal behavior or isothermal. So these are three properties of temperature. So when I'm talking about the thermal structure of my atmosphere, from ground level till up to 11 kilometers, my temperature is falling at a lapse rate. Then from 11 kilometers up isothermal value, then beyond 20 kilometers up to stratopause, my temperature is increasing again. Okay. Just a second, student. Give me a second. Okay. Now what happens after stratopause or stratosphere? After stratosphere, the temperature is further going to increase at a tremendous rate. And then it is going to and then the temperature is further going to decrease, then it is going to be isothermal, and then it is going to increase again. This is how the temperature behaves. Decrease, isothermal, increase, decrease, isothermal, increase, like that. And when you go into detail, the reasons are also explained as to why. Now this mesopause, students, this mesopause can be told to be there up to 80 kilometers from the ground surface. So irrespective troposphere, stratosphere, mesosphere, thermosphere, the atmosphere is also divided into two simple spheres known as homosphere and heterosphere. So from ground level till 80 kilometers, atmosphere is also called as homosphere or the layer. So up from here till here, this part of the atmosphere is often called as homosphere. So these are important points. Somebody says, what's the altitude till which homosphere exists? You could say that it exists up to around 80 kilometers. And above homosphere till maximum range. Above homosphere till maximum range, I have heterosphere. And very interestingly, students, another subdivision can be made where starting somewhere from 60 kilometers, up to higher altitude, I have a different name for this sphere known as ionosphere. And you put an asterisk to ionosphere because your ionosphere is very important for your radio waves, for communication, for navigation. So your ionosphere will start from 60 kilometers. So this is your thermal structure of your atmosphere. And last but not the least, you must have all heard about this property. Let's make it in yellow color. And the property is ozone gases or ozone layer. Remember, in the list of gases and traces of gases, we had also included ozone. If somebody has to ask you what is the area where ozone is concentrated, then you will say that the ozone generally starts from, let's say, around 10 to 11 kilometers, okay, and goes up to 50 kilometers. So my ozone will start from 10 and will go up to 50 kilometers. Now, are you required to remember all these kilometers ranges? Students, if you really want to remember all these kilometers ranges, you won't have to by heart it. You won't have to mug it up. You just have to understand it. And all these points will be stored into your memory permanently. You just have to reread and redo it again and again. After the session, reading the text, your job is done. Simple as that. And amongst this 10 to 50 kilometers, 40-kilometer range that I have, where I have ozone layer or ozone gases, the maximum concentration of ozone is between 20 to 25 kilometers. Max ozone, 20 to 25 kilometers. And then I have lower ozone. Ozone gas is important because the rays of the sun, the ultraviolet rays of the sun, they are harmful to us. They can give us skin cancer, they can give us cataract, but ozone will observe those. So ozone is a good gas. Okay. Now this is the thermal structure of the atmosphere. These are different layers, different pauses, the lapse rate, temperature falling, temperature increasing, ozone, ionosphere, homosphere, heterosphere, and so on. You have to just understand this concept nicely. Couple of times you will have to look at the diagram to make sense of it. and then it will be very clear to you how much atmosphere is where, what is happening where, and so on. One more thing I wanted to discuss was international standard atmosphere, but we'll be doing it in the next lecture. It will make more sense to study that in the next lecture. In the same lecture, I also wanted to talk about this water vapor. Let's say that air is 100%. Okay. Let's say air is 100%. If out of this 100%, water vapor content, okay, is 4%, it means air is 96% left. Then air is called as saturated air. Note, 4% water vapor is max water vapor holding capacity of air. Students, this water vapor is not good. Saturated air is not good. It will impact your lift, it will impact your thrust also. In such a case, RH. Now I'm just introducing these concepts. You don't have to dwell deeper right now. Subsequently, you will be learning it. In such a case, RH, that is relative humidity, is known to be 100%. It means air has max is 80%, means water vapor is less than 4% in the air. Saturated air, students, not good. You will experience breathing difficulties also in saturated air because water vapor is more, it means oxygen is less. You'll feel heavy. You'll feel fatigued, exhausted. Okay. If water vapor is less than 4%, air is called unsaturated air or dry air. Dry air is good. Unsaturated air is good. This can be a difficult topic, students, but I don't think it is difficult. It's just that how you introduce, when you learn these points, that you see whether something is easy or something is tough. So take a quick look at what we have done. Talking about meteorology being the science of atmosphere, we started learning about atmosphere. It's a homogeneous mixture of gases called air. And what are the gases? Four major gases: nitrogen, oxygen, argon, carbon dioxide, and traces of so many different gases, plus water vapor and solid particles. How is the composition done? Composition is such that up to 6 kilometers, half of the atmosphere is there. Up to 10 kilometers, 3/4 of the atmosphere is there. 35 kilometers, 99% atmosphere is there. Amongst this atmosphere, there are different layers. They have specific properties. Troposphere is of major concern, and troposphere ends at tropopause, wherein on polar regions, the tropopause is up to 8 to 10 kilometers, and so on. That's it, students. Do a mental revision. We are ending the session. Whoever wants to leave, you can leave the class now. I'm also wrapping up. Do a mental revision. Whatever doubts you have, you will drop me a message. And especially those students who are taking your first live lecture, I will need a feedback from you, positive and negative, and what we can improve to give you a better session. And other students also, please feel free to give me a feedback if there's anything negative, so that in other lectures we can improve upon it and give you a better training experience. Okay. Do a revision, be very comfortable. Do not rush anything. Go with the plan, and you will realize that by the time your exams come, you will be easily able to clear. Mohammed Azam, please go ahead.
Sir, you said you will be sharing a document for a revision purpose.
Yeah, you will have to give me some time, students. I will do it by Friday. Maybe today, maybe tomorrow, maximum by Friday. But I'll share a PDF and I'll share an email to everyone. It will just be a picture of this chapter converted into a PDF for your revision purposes, chapter by chapter. I'll be sending it to you. I'll try to send it ASAP. Maybe tonight I'll try to do it if possible so that you can revise. There'll be few more points that we have not discussed. Make sure you note those points, remember, and add it into your notes. Okay. A lecture and reading from the text will sum up your preparation for metrology. It's that easy. Just reading, I'm not even asking you to memorize. Getting it? There are more things in this chapter that we'll be learning, okay, in next session. And then we'll be picking up with respect to the first important property, that is pressure, then temperature, then density. I'm giving you all a heads up. If you can master pressure, temperature, and density, you can master metrology. What did I say? If you can master pressure, density, and temperature, you can master metrology. Got it, students? Pressure, temperature, and density. These three things is what the whole meteorological experiences and weather elements and winds and all these other parameters are all about. Okay, let's call it a day. I'll see you all in the next class. Of course, your next week's schedule is not yet out. You'll be getting it over Friday or Saturday. Accordingly, we'll attend our sessions. We'll try to accommodate. Until then, if you have any questions, please ask, and please remember to give a short feedback over a WhatsApp message to me. Especially students who are learning for the first time in the live class, like Yuvraj, Abhiroop, Lakshay, you also drop me a message. Others, with respect to metrology, you can drop me a feedback so that we can improve. Got it, students? In the RT lecture 8:15, whoever is joining us, Alpha 22 batch. Okay? Bye, everyone. Take care, and thank you for being such a nice class. I'll see you next time. And make sure you all smile and enjoy. I forgot to mention it again. I'll do it for the first few lectures till the time you get a hang of it. Take care, everyone. See you soon.
Thank you, sir.
Most welcome, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.